Welcome back to section 8.5, angles of elevation and depression. We're going to start off and define what an angle of depression is versus an angle of elevation. From this drawing, we see that we have a plane, and here we have all four angles listed. And so it says that angle 1 is an angle of depression from the plane to the tower. And that should make sense because you look at the plane, it's looking down like in if you were inside of the plane and you look down at the tower, you would look down at it in angle form, but that would be an angle of depression because you're looking downward. On angle 2 would be an angle of elevation because you're at the tower and you're looking up at the plane. So that would make sense. You're inside this tower and you look upward, that would be an angle of elevation. Angle 3 would be an angle of depression from the tower down to the person on the ground. And if you were that person on the ground and you were looking up at the tower, you would have an angle of elevation. Alright, using those new terms, we're going to solve some of these problems. And of course, the way that we're going to solve these problems, that they will form a right triangle, which means we can use SOHCAHTOA. So we're going to use trig in order to solve these problems. Again, anytime that you see trig, you always think of SOHCAHTOA, sine, cosine, and tangent. Alright, so on problem 1, our notes were nice enough to draw a picture for you. We have a surveyor standing 200 feet away. So here's our right triangle. Just like when we measured our flagpole, we're going to say that we're up 5 feet. So we'll have to factor that in once we solve for the height of the building. So when I look at x and I look at 35 degrees, I should recognize that this is the opposite side. And then the 200 feet would be my adjacent side. And then the side opposite our 90-degree angle will always be our hypotenuse. So we're going to solve for x, and I see opposite and adjacent. That lets me know I'm going to use TOA, or tangent. So tangent 35 is going to equal x over 200. And then we're going to enter that into our and when I enter that in, tangent 35 is going to equal 0.70 equals x over 200. Let's cross multiply. We get 140. Alright, so x is 140, but remember we have to add back this 5 feet since we're up 5 feet. So the entire height of this building would be 140 plus 5, or 145 feet. Alright, to our other problem. Again, we have a plane. It's flying 3,500 feet above. It's going to begin a 2-degree descent to land at the airport. How many miles from the airport is the plane when it starts its descent? So in this case, we're actually trying to find the hypotenuse. Alright, and angle 2, this is going to be an angle of depression because we're looking down. But again, we're still using trig and SOHCAHTOA to solve this problem. So whether or not it's an angle of depression or an angle of elevation, we're still going to use trig to solve it. So from angle 2, I see that I have the opposite side, and side x is opposite our 90-degree angle, so this is our hypotenuse. And since we have opposite over hypotenuse, this means that we have sine. So we're going to take sine of 2 degrees equals the opposite, 3,500, over hypotenuse, which is x. We enter in sine of 2. We get a very small number, 0.035 is equal to 3,500 over x. We're going to cross multiply, 0.035x equals 3,500. Divide by 0.035. So 3,500 divided by 0.035, and we get 100,000 miles. So x is 100,000 miles. Actually, are we miles? No, we're feet. X is 100,000 feet. That would be a long way if it were miles away from the airport. All right, the algebra review, we're definitely going to solve these. These problems have been an issue for us all year long. So let's hit the pause button on this video, and we'll have you try these 3 problems, and then in about 5 minutes you can hit the play button and we'll see the answers that I get. Hopefully they match yours. Alright, x equals -2 is going to cross the x-axis at -2. Y equals -3. It's going to cross the y-axis at -3. And then these have an intersection point of -2, -3 is the point of intersection. Alright, on this problem, alright, a few different ways. We can graph this using x and y intercepts, but we may not find the point of intersection. But let's go ahead and try it. X is going to be 8, and then y is going to be -8. And so there's one line. And then on this graph, we have x is going to be 2 and y is going to be -2. Alright, so if I were to solve for y, I would get -y equals -x plus 8, y equals x minus 8. And with this graph, I would get y equals, oh, you know what? I made an error. Uh-oh. Alright, let's erase this. Yeah, that was not good. This graph I made an error on, and my error was that the x-intercept in this problem was going to be -2, and I put +2. So this is where the line should go, and then we're going to draw this line. Alright, here's our point of intersection. Unfortunately, the only way that I can find out this point is I have to solve for y and find my slope. So we're going to do that now. Y equals -x minus 2. So down 1 over 1, down 1 over 1, down 1 over 1. Alright, this is the beginning. Very challenging to see. Looks about right there. Then y is equal to x minus 8, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Good. So there's our point of intersection. That point is going to be 3, -5. When I plug in 3 and -5, both of these conditions are met. So that works. Alright, y is equal to 2x plus 7. Rise 2, run 1, down 2 over 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 1. And then -y equals -3x minus 9. Y is equal to 3x plus 9. So we're going to go down 3 over 1, down 3 over 1, and there's my point of intersection right there. Alright, so that point is going to be -2, 3. Again, let's plug these back in for x and y, make sure that they work. And I believe those work as well. Alright, thanks for joining us. See you next time.